is up, my dudes? Welcome back to Corona and Code. Today we're going to talk about Booleans and expressions. So, what is a Boolean? A Boolean in Python is just true or false with capitals. If I just type true, I get a problem. If I just type lowercase false, get another problem. In Python, we only care about capital true and capital false. So if I go and I try to do the type of true, I'll get the class bool. So that is the type of a boolean in Python is bool. So what are the things that I can do with booleans? So I can use different operators to try to figure out whether something is true or false. So the main thing that you'll see with Booleans is something along the lines of if this thing is true, then print it's true. Expected an indentation. Let's just type it over here. So if I do if it's true, print it's true. So go ahead and run this. Should print it's true. So if I switch this to false and I run it, it doesn't do anything. So those are the only two things that happens with if, is that it either runs it because it's true or it doesn't run it because it's false. There are no other possibilities. So everything that ends up inside of this if statement has to eventually resolve down to either true or false. I can't put the number 2 here. It might actually let me do something because the number 2 exists, but this isn't particularly helpful. If I just put if 2, alright, well, what is that? It's not very useful. So we need to use something called Boolean operators. So you guys probably remember these truth tables from Snap. So there are two kind of operators. There's the AND operator and there's the OR operator. So if I have true and true, and I run that, I should get true. And we can see that through our truth table here, because at the top we have the first one, so we have true, and then we look up the second one, which is on the left-hand side here, and we find true. Okay, where do they intersect here on this little table? Oh, looks like it's true. That's what we got. If I do true and false, and do true and false, so if I look up true here, and then look up false, I expect that I'm going to get false. So that's how that works. I mentioned here multiplication because if you think about true as being equal to 1 and false is equal to 0, if we multiply 1 times 1, we'll get 1. If we multiply 1 times 0, we get a 0. So that's one little trick for trying to remember what it'll look like. So a similar thing happens with OR, which is it only cares if one of them is true. I consider this one to be addition. So if I do true or false, I should get, see, I do true or false, I should get true. Run that, and I get true. And I think about addition or as addition in the same way, where true is equal to 1 and false is equal to 0, and all I need is a number greater than or equal to 1. So if I do 1 plus 1, I'll get 2, which is greater than 1, or greater than 0, so I get true. If I do false, which is 0, plus true, I'll get true, because I'll do 0 plus 1 equals 1. Or even with false, 0 plus 0 equals 0. I can show that there. So false or false, and resolve that. So we get false. So when we're trying to resolve some more complicated things, we can have something like, let's say that we have we have a really complicated expression. All the if statement is going to boil down to is true, true, or false. That's all it's going to resolve down to. So let's say I have some statement that's like true or false. Well, all this is really going to boil down to is it's going to resolve to true. Let's say I make it even more complicated. Let's say I do true and true. Well, okay. First we have to do same thing with mathematical expressions. We do the parentheses first. So we'll resolve this one. So we get true. And then we leave everything else. So bring the parentheses down, bring the false down. Well, I hope to bring the false down. So now we have true or false. Okay, well, we already did that one. That one's going to be true. So when we have these more complicated expressions right here, then all we're going to do is just resolve them one at a time, not make it too complicated, and then put them in here, and then eventually it will always just boil down to true or false. So now that we've got some Boolean operators, let's see how we can use this in a more useful way. There's also two more operators that are important. So one is not true, and this just turns true into false. And again, I'm sure you guys can kind of see where I'm going. What happens when I do true, when I do a not on false, just turns it into true. So same thing here. If I do not true and true, well, first thing we need to do is we need to resolve the inside. So let me just copy this whole thing. So you resolve the inside, not true. What is that going to turn into? Well, if we look up here, it's going to turn into false. It's going to turn into false. It's not true. It's going to equal false. So go ahead there, replace that, false. Okay, well, this expression is a lot simpler now. False and true. If we're going to look at we have false, we have true, we're going to end up with a false. So give us false. And we can even put this in here to see if it's true. Comment that out, run it, and we'll see that it was false. If I change this to not false and run it, it should give us it's true. So that's one thing we can do. Another thing that we can do is we can test to see if true is equal to true. So this is the equality operator, different than assignment, which is just a single equal sign, is equality, and equals is assignment. So whenever I see this, I always think of this thing on the left is equal to this thing on the right. So I have true is equal to true. If I try to resolve this, I'm going to expect that they're, I would really hope that they're the same. They're equal. So I go ahead and run that, and I get it's true. So we have and, we have or, we have not. Just looks like not. We have equal, equality, and that's just double equal sign in Python. We have and, which is just lowercase and. We have or, which is just lowercase or. Alright, so that's useful for Booleans. Now, what we're going to need to turn some things into Booleans, okay? So, the most common thing we're going to have to turn to Booleans are numbers. So, we're going to have some numerical expressions. So, there are some operators in Python for numbers. So, they are, these math Boolean operators. Let's move this down here. So our math Boolean operators are less than. This one's greater than. This one is less than, and then equality, because we can check to see if things are equal. So I show you the greater than. So 10 is greater than 3. Is that true? I hope so. It's going to resolve down and say it's true. You can do the same thing with less than. So 2 is less than 3, and then do run. If I do something over here, I'm going to show you that if I do 2 is less than 3, and I hit enter, we see that this gives me back a Boolean. So I took two numbers, two integers, and with the less than or greater than operator, I returned back a Boolean. So again, all the things that are in if statements, they just resolve to Boolean. So kind of looking at the example we had earlier, if I had 2 is less than 3, it just resolves to true. I can do the things that are even more complicated. I can do things like 2 plus 1. Well, is that less than 3? I hit run. Oops. Put that in here actually. So 2 is less than 2 plus 1 is less than 3. I go ahead and hit run. Well, that doesn't print anything because 3. I resolved this down to 3 is less than 3, which is false. If I wanted to say if it's less than or equal to, then I just add an equal sign to the end here, and it'll say, okay, is 3 less than or equal to 3? Okay, well, it is equal to, so we can go ahead and give it true. That'll end up being true. I'll throw that in here and just show you that it works. All right, so we have greater than. We also have greater than or equal to. We have less than, and we have less than or equal to. And then the last thing, it's a little obvious here, but we can check to see if things are exactly equal. Exactly equal. So we do the same thing. So this will be 2 plus 1, which resolves to 3. And is 3 equal to 3? Well, yes it is. So I hope that this prints out true. So there you go. So these are all the things that we can do with Booleans here. So remember, for math Boolean operators, we have greater than or equal to, less than or equal to, and equality. For Boolean operators, we have not, and when it turns that on true, it turns it into false. We have not, we can do it to false. We have equal sign for equality. We have and, which is kind of like multiplication. And we have or, which is kind of like addition. So using all of these, we should be able to do a whole host of different things with computers. I kind of call Booleans as like the foundation of computers, because it's really just, this is what a 1 and 0 is, man. This is it. This is the hype. So hopefully we will be able to do our next project with it, and I'll see you guys in the next video.